Hello scholars, welcome back to the Kemet Maasai Academy. What we're going to be doing today is plotting quadratic graphs. We're going to try to do two of them, and they both have negative coefficients in front of the variable. Now the quadratic graph, the highest power of a variable in a quadratic graph is 2. So it will be an x squared or whatever the variable is the highest power or degree is 2. You could have also a variable with a power of 1 or 0 as well, but the highest power is 2. So we're given our equation and we're going to be plotting them on the coordinate plane, the graph. Now we are given also a domain which tells us where our x values begin and where they end. Now if you watch the video that I did, two videos actually that I did on the linear graphs, you would have seen where I only got the values for the endpoints of the domain, and I also used 0 because the linear graphs gave us a straight line. For the quadratic graph, however, we need to account for every single point from the end to the next end, every point in between, because the quadratic graph gives us a curve which we call a parabola, and in order to draw that curve we really need to get all those points to get that smooth curve. If we leave out any of the points, the parabola is not going to look fluent, right? There's going to be, it might even end up looking rigid or straight, and the quadratic graphs produce a curved line, not a straight line. So you don't use your ruler to connect the points in your quadratic graph. You take your hand and you gently connect the dots as smoothly as you can. So we're going to be ruling off our table. Remember, we're going to account for all of our domain values, our x values from -3, -2, -1, 0, 1, 2, 3. All of them. Now we go back to our equation and we see what are we going to do to our x values to get our y values, because ultimately we want our ordered pairs. So we can plot them on the graph. So it says we're to square the x's, multiply them by -2, we're to also multiply the x's by 3, and then we combine those two, we add them. In this particular equation, there's no constant term, or rather, the constant term is 0. So that's an indication that this graph is going to cut the axis at 0. So, but we have an x term and we have an x squared term. So the first thing we're going to do is to square the x. Always start by squaring the x. Then we multiply by the -2, so the x squares that we're going to multiply them by -2, and we're going to multiply the x's by 3, and finally combine them to get our y values. So let's start by squaring the x's. So -3 squared is a +9, because -3 times -3, that's +9. -2 squared is a +4. -1 squared is a +1, 0 squared, 0, 1 times 1 is 1, 2 is 4, 3 is 9. So these x squared values, we're going to multiply them by -2. So -2 times -9 is -18, -2 times 4, that's -8, -2 times 1 is -2, -2 times 0, -2 times 1, -2 times 4, and -2 times 9. And now we're going to go back to our x's now. The x squares, multiply the x's by 3. So 3 times -3, that's +9. -9, sorry. 3 times -2, -6. 3 times -1, -3. 3 times 0, 3 times +1 is +3. 3, 2, 6, 3, 3 is +9. So now we're going to combine them. However, We don't start from here. Go back to your equation. Whatever the first term was in your equation, that's where you start. So the first term was negative 2x squared. This is where we're starting. Even though we squared our x's first, but that's so that we could multiply by the negative 2. This is our first term. See? This is where we start. So it's negative 18 minus 9, which is negative 27. Negative 8 minus 6, negative 14. Negative 2 minus 3, negative 5. 0. Negative 2 plus 3, that's 1. Negative 8 plus 6, that's negative 2. And negative 18 plus 9, that's negative 9. So now we can write our ordered pairs. 1, 2, 3, 4, 5, 6, 7 of them. So negative 3 on the x goes to negative 27 on the y. Negative 2 on the x to negative 14. Negative 1 on the x to negative 5. 0 on the x to 0. Remember we said this curve is going to cross at 0. We knew that because the constant term was 0. And the constant term tells you where your curve will cut the y-axis. Okay? So 1 to 1. 2 to negative 2. And 3 to negative 9. So we're going to quickly now rule up our coordinates plane. We're going to put in our 0, 0, dead center. Put in our y-axis here, our x-axis. Now for the x values, the range of the x values is negative 3 to 3. We can spread out our x-axis, right? So 2 centimeters to 1 unit is a good way to do the x-axis. So 2 little boxes, that's 1. 2 little boxes, 2, and so on. 3, 4. Same thing on the negative x. So negative 1, negative 2, negative 3, negative 4. On the y-axis, our biggest y value in terms of digits is 27. It's a negative 27. We can go up then by 5 on the y-axis. 1 centimeter to 5 so that it fits on the page. So we can't use the same axis that we use on the x. It would not fit. The y values are bigger. We need a different scale. So let's go up by 5 on the y. 5, 10. So that's 1 centimeter or one little box on your graph paper. 15, 20, 25, 30. Same scale on your y, your negative y. You have to maintain the same scale on each axis. So let's plot now our ordered pairs, right? Our ordered set of coordinates. Negative 3 on the x to negative 27 on the y. So negative 3 down to negative 27. I have to be estimating, but on your graph paper, you will have it accurate, very accurate. Negative 2 on the x to negative 14 on the y. So that's negative 2 on the x down to negative 14 on the y. That's negative 15, so negative 14 is about there. Negative 1 on the x, negative 5 on the y. So negative 1 down to negative 5. 0, 0, that's right here, dead center. Bullseye. Bullseye of the graph paper, 0, 0. 1 to 1. So 1 on the x to 1 on the y. That's there. 2 to negative 2. So 2 on the x, negative 2 on the y. Negative 2 is about there. So positive 2 on the x, down negative 2 on the y. And finally, 3 on the x to negative 9. So 3 on the x, down to negative 9 on the y. So what we're going to do now is to connect our points. Remember I said this is a quadratic graph. We're going to get a curve. You are not going to take your ruler and try to connect these points. You do that for a linear graph, which gives you a straight line. Here now you're going to use your dexterity and you're going to try your best to get a smooth curve. Okay? It's not always going to be a complete parabola. Alright? But Sometimes it's going to break, just a part of it. Sometimes you're going to get your full parabola like that, sometimes like that, or just half of it, or a quarter of it, right? So now we write our equation on the graph, y equal negative 2x squared plus 3x. Now I want you to take note of two things. Where does the line cross the y-axis, and what is the inclination of the graph? It's a negative coefficient of the x squared term. Notice that the graph is inclined this way. It's not inclined this way. So we're going to do another negative coefficient graph just now, and we're going to see if it's the same inclination. And you can check the video that I'm going to do on positive coefficients of the quadratic graph and see how those are inclined, right? So notice it crosses the y-axis at 0, 0 because there is no constant term, or rather the constant term is, we could have put a plus 0, we just didn't have to. But if you don't see a constant term, it means the constant term is 0 and it will cross the y-axis at 0, 0. The negative coefficient tells you that the line will be inclined, like the curve will be inclined that way. Or if it's just half of the curve. So let's do this other graph. This time, a constant term is there, but there is no x term. Or rather, the x term is 0. But remember, the constant term is what tells us where the graph will cut the y-axis. That's the y-intercept. So we know it should cut the y-axis at positive 6. It's a negative coefficient. We know we're going to see if it's the same inclination as this negative coefficient 1. And then we can say, well, maybe this is a pattern. When the coefficient is negative, this is the orientation of the graph. So let's see. The domain tells us from negative 3 to 2 for our x values, negative 3, negative 2, negative 1, 0, 1, 2. We're going to square our x. It says negative x squared. We need to square the x first and then make those answers negative. That's a common mistake that's made. Persons just plug in the value and as a negative and square it, you'll end up with a positive number. Square the x first, so write your x squared first and then make those values negative, and then you add 6. So, squaring each of these, negative 3 squared, that's 9, negative 2 squared, that's 4, negative 1 squared is 1, 1 squared is 1, 2 squared is 4. Now we make them negative, just change them to negative, because it's negative x squared. And now we add 6. So finally we can get our y values. So we start here, wherever the equation started, that's where we start. Not here. Negative x squared, this is where we start. So negative 9 plus 6, that's negative 3. Negative 4 plus 6, that's positive 2. Negative 1 plus 6, that's 5. 0 plus 6 is 6. Negative 1 plus 6, that's 5. And negative 4 plus 6, that's positive 2. So let's quickly plot our graph. I'm noticing we have only one negative term here. So what this tells me is I can manipulate my graph. Since I have only one negative term, or if you look and you only see a couple negative terms and a lot of positive terms, you don't have to draw your graph dead center. You can leave more space for your positive axis and just a little space to accommodate your negative numbers, so you utilize your graph intelligently, right? So since I only have a negative 3, I'm going to make my graph, I'm going to put my x-axis further down there to utilize the positive axis where most of my numbers are positive. Alright, so on the x-axis is negative 3, so I'm going up 1, 2, 3. On the y, same scale, -1, -2, -3. I can go up by 2 on the y-axis because the numbers are still pretty small. I don't have to go up by 5. So -2, -4, 2, 4, 6, 8. We can stop there because the biggest number is 6. Alright. So let's plot now. This is our 0, 0, dead center, bullseye. So let's write our ordered pairs though. So -3 to -3, -2 to 2, -1 to 5, 0 to 6, 1 to 5, and 2 to 2. Alright, I'm lacking space, but I would have put my ordered pairs neatly. So all of this information would be around the back of my graph paper, and to the front I would plot my graph on the ruled up boxes, right? So likewise, so all of this here would be at the back of my graph paper, and the graph itself would be on the front. So I'm plotting -3 to -3, that's here. -2 to +2. -1 to +5. 0 to 6. 1 to 5. And 2 to 2. Alright, so let me see the inclination of my graph. So it's going this way. And I'm going to write my equation, y equals -x² plus 6. Now you notice it's the same orientation as this graph. The same general orientation, right? And it does cut the y-axis at +6. Remember, our constant term tells us where the line will cut our y-axis. If you don't see a constant term, it's going to cut it at 0, 0. If you see a constant term, this is where it should cut the y-axis. If it doesn't, then you did something wrong. So you need to go back and check, right? So generally then we can say when the coefficient of the x² term is negative, the general orientation of the graph is this. Whether it's a half of a parabola or a full parabola. Some people call it a frown face, the frown. And for the positive, we say it's a smiley face. If that's your way of remembering it, that's fine. Right? So check the video that I'm going to do now on quadratic equations with a positive x² term. And we'll see the orientation of that. Also check the graphs that were done on the linear equations, whether they were positive x coefficient or negative x coefficient, so you can compare the orientation of the graphs. Alright, so if you have benefited from this video, just drop a line to say thank you, miss, and share the video so others can benefit also. And if you want me to do a video on any topic at all, just let me know in the comments. If you have not yet subscribed, please do so now. I'll see you in the next video.